Welcome back to the coding stream. It has been like a long time since I posted a video because I was busy essentially on some interesting Rust project, which involved a lot of work in the libp2p library. And I would like to share essentially some things I learned while working with it, because I found it very difficult without any guidance, without any actually expert helping me guiding through it, to figure things out. So what is libp2p, right? libp2p is a peer-to-peer library which helps set up essentially connections between multiple machines, and it's optimized to do this over the internet using a variety of let's say protocols, and it deviates from the normal client-server model, which essentially is what we normally use day to day. We request, let's say, a web page from a web server, so I'm the client, and I request something from the server. So the fundamental difference with peer-to-peer network is that essentially with node or peer is both a client and a server, and this also is reflected in how they are connected to each other. So what is libp2p exactly? So libp2p is developed to support the development of peer-to-peer networks, and for this it uses a kind of a philosophy. It's a very complicated library, especially when you're not, what I said before, let's say, have any guidance of working in it. So let me show you a little bit, essentially, how I progress through the peer-to-peer. There's one little caveat, and that's like I'm gonna use like a new version of the library, which is version 0.531. I think the latest is this one, 0.532. And the reason I'm doing this is because, it's also nice to see how somebody which is versed in Rust, how he figures out things. So I have no previous exposure to this, the peer-to-peer library. So in that sense, I'm just essentially working just as you, trying to figure out how things actually work. So they changed a lot. So the version I worked with was version 0.441. So first of all, they have something now that's called a swarm builder. They have some ergonomic changes like non-exhaustive, which means enums are non-exhaustive, which means essentially like you can leave out certain branches and the compiler won't check them. And especially this thing I'm curious about is smart to keep alive algorithm, which seems to improve a lot of stuff. And for the rest, some really interesting changes, also this tracing library. So the software I developed was on 0.41, so this is also an exercise for me, essentially, to know exactly how to convert my old code, essentially, well, let's say the code that's based on version 41 to 5.2. So without any further ado, let's start a new project. And what I'm creating now essentially is say a Rust project, which will use the peer-to-peer and will enable some features. So let's go through the peer-to-peer first, right? So what are the main elements essentially of the peer-to-peer? So let's start our Vim editor. So just as an explanation, right? So libp2p has the following elements. It has a network behavior, and it has something what we call like a connection handler. And these are traits. And it has like a main component, which is called the swarm. And the swarm essentially handles dialing, setting up a listening socket, handling the transport, connection establishment. But also, let's say, protocol negotiation. And so essentially, like, it handles all the tough stuff, right? But also, very important, it also handles something essentially which I really like. That's called like concept like hole punching. And it handles, if you configure it, a thing called like a ready full service. So this stuff, hole punching on the Vushans, is very complicated to do yourself, right? And also, let's say, implementation of a transport, optimizing this and everything like this. Of course, essentially, it's a lot of work, right? So we get a lot. We get a lot for free, essentially, like using um, this library. So um, so now we covered this. So buckshot. So what am I going to build? So what buckshot is going to be is a network behavior which samples a set of nodes, fetches the preferences, fetches a preference from the set of nodes, accumulates them. So we get in the end essentially an object which is the sample outcome, which actually contains all the responses of the individual PS. Yeah, so this is the thing I want to develop here as a test application. It's a very simple protocol which we can run on a swarm. To do this, we're going to build it up, let's say, step by step. Yeah, so I'm going to start with tests. Then we're going to start. So for this, we need also some features enabled of libp2p. So let's see what kind of features libp2p has and what we probably have to enable. So Tokyo runtime, we want to use the macros, we want TLS, TCP, and noise to get started. Okay, so let's create a test. Test, let's say ping. Let's start with a simple thing, right? So how do we do this? So we need to first of all create a swarm. Let's also see essentially if all the features are enabled. Okay. So let's see the swarm builder is swarm builder new. So again, so I never actually use this. So let's see. What I normally do is you either read the documentation or you go directly to the code, right? And what we see here already is interesting. We also need a feature. Do we enable this? Let's see. So what we have here is an example, and I like it already, right? Because of the simple function with new identity, which probably generates a random identity, which we can use. And what is an identity? It's like a public-private key pair using a certain curve. I think, let's say, libp2p use the Edwards curve for this. So let's do this. Let's see. Import Exactly. So let's see if we already got, okay, so what does this do? Exactly. It generates like a key pair of the Edwards curve, and it does with existing identity. So essentially it's like helper to get a random identity. That's exactly what we need. It selects the Tokyo runtime. It selects TCP protocol with default settings. So I cannot branch into this for some reason. Then it implements a dummy behavior, which probably does nothing. Okay. So this is now a swarm, right? So let's make this into a separate function. That's correct. So the function name here is create swarm. So let's swarm 0 is create swarm. And we need 2, right? So we have 0 and 1. And this essentially returns here this dummy behavior, right? So what we can do, for example, is get this included. So return this thing. Okay. So let's see. Swarm. We got this behavior. Let's do this dummy behavior. Let's do it like this. So libp2p swarm dummy. Let's call this dummy behavior. Okay, so we created a simple function that returns dummy behavior. Okay, so now we need to execute this, and for this we of course need a runtime, right? So we need to add Tokyo to our project. I'm not going to do anything difficult because we can just fix this very quickly. So we see something else. We get an error here. So this error is interesting because it says we add the features like TLS and YAMUX, right? But it says, okay, it cannot find them. It has to do essentially with the way libp2p imports these libraries. And YAMUX it still cannot find. So that's interesting. So let's see. Let's see what kind of features we need. YAMUX doesn't have. Yeah, but has YAMUX. Okay. Okay. So now we got Tokyo int called. We can essentially create a runtime. So let's say runtime is Tokyo runtime. Now we got a builder. Thread. So essentially, we're now essentially creating a runtime for people who don't know what a runtime is. Like async Rust requires a runtime to execute async functions. So the runtime essentially is the bridge between the async machinery of Rust and the operating system, right? And this can be different for example, normal operating systems like Linux and Windows and Mac. and for example, embedded software, right? And you can even do all kinds of stuff with the async machinery, even if there's no real I/O involved, right? So, but that's a whole other discussion, and maybe I'll make another video on this subject as well. But essentially, so we need the runtime to run this stuff. So let's say we spawn one. So Copilot gives something interesting here. So blog on, let's say spawn one. Dial. Some options, and we need to also let swan zero list, for example. So exactly. Let's listen on localhost on some kind of port. Let's make the example very simple. So let's make a direct port here. Make it 8. Okay, and then host this. And here essentially we are going to dial. This is not going to work because of move semantics, so we're going to do it like again. Uploaded address here. 4 27.0 Okay. So here already, let's say a lot of stuff is happening, right? So here you can see essentially, so what is this? Well, so these is what we call like a multi-address. And this is created by a crypto, let's say, company. I thought it was IPFS. And they made this new kind of format which can address different kind of protocols, IPv6, quick, any UDP, let's say in a kind of a string format, but it can also essentially stack those. So you can have another protocol, for example, blah, over this with some kind of key, right? And that would signal essentially like different protocols that can be stacked on top of each other, right? And they call this the multi-address format. And when we do this, look at the listen on function, if I can enter that, I cannot restart the project. So this also gets included. So let's see. Okay. For some reason I don't get put here. There's something wrong. There's something wrong. Candidate version. That's interesting. So let's try to figure this one out. It says, okay, yeah, mux cannot find a specific version, which is a bit weird. So let's try to figure this out. So I'm going to disable this version for a moment. Okay, application working. So it's building. So it needs an explicit version. So I want to try to find the correct explicit version, which seems to be like text. Okay. Now we get error messages. So let's see what kind of cargo they have. That works. So they're using this one. So it's 0.5.1. Okay. So let's use this also for our project. Oh. So let's see if this builds. It builds. Don't like it that I have to specify this explicitly, but okay. So now it says something interesting. Into dial options. Why? Because it doesn't know exactly what to parse. So let's make this a multi-address. And here already like a lot of stuff is happening. Eh? So I'm indicating to the type of parse, right? In the generative parse that has to parse to a multi-address. If you look at the dial function, it says, okay, I implement into something that implements into dial options, right? So that means the dial options probably has an implementation here, as you can see, that says, okay, from multi-address for dial options, right? So that means essentially, okay, if I get a multi-address, I can transform it into a dial options, and it does this by specifying. It doesn't know the PRD, but it knows the address, and then it builds something, right? And here already we are like deep into the balls of essentially like the peer-to-peer of all the options you have, right? So dialing essentially means I want to make a connection to another peer. And when you initiate the dialing connection, you actually like establish a connection to this other peer. So this listen on doesn't require this type hints. Right? It's interesting. Because probably listen on will take a multi-address exactly. So the parse knows how to parse a string into a multi-address. So now we have here one that's listening on it, and one that's dialing. Now, how libp2p is implemented is very important, right? So let's first down a little bit into the dialing and how libp2p does, like say, network connections, right? So for example, if I have like a peer 0, and the peer 0 is connecting to peer 1, what actually happens is peer 0 is a dial, and peer 1 is the listener. And once a connection is being established, that means essentially that peer 0 and peer 1, remember, they're both client and server, now have a two-way connection to each other, right? So they're both client and server to each other. But still is remembered that peer 0 was the dialer, and peer 1 was the listener. And this, I think, is very important to understand, because you actually have like an inbound, so peer 0, for example, has an outbound. So when you implement a protocol, it has an outbound which goes to peer1.inbound, and the other way around. So you got peer1, peer0 also has an inbound, and then essentially peer1 is an outbound, right? So it's like a symmetrical connection. They're both connected the same way. So also in your code, you have to, let's say, remember this, right? So what we're actually doing here now is, okay, I'm running here, spawning an async task on a runtime, right? Which starts a listen, let's say swarm 0 in the listening mode. And I'm here blocking on an async, which actually dials. Now comes the following thing to understand, which will save you a lot of time if you don't understand this. Like swarm 0, which is the swarm object. If you look what this implements, then you see that it implements future stream. Yeah. And what stream essentially means is, okay, this is let's say an object which will essentially process essentially events. So this pull next method, as you can see, implements here a swarm event towards a behavior, right? So that means essentially that pull next has to be called, and that actually like triggers the whole, let's say, swarm. Uh, it triggers the whole swarm behavior and will run all the behaviors, right? And these behaviors will fork off connection handlers and all the same. So if you don't call this, then the swarm will not do anything, and I will show this later as well. So if you go here into pull next event, for example, then we have what you see it will do. So this is in the guts of the swarm object, right? It tends the test for pending swarm events, takes the first. Pending handler events will take one, right? It will actually do all kinds of stuff to communicate with the connections handler, which they have spawned essentially on the runtime. I'm not going to go too deep. Maybe we'll do that another time. But for your understanding, the swarm 0 needs to be pulled. It needs to be pulled. So we're going to do this while that's some event. Swarm. Next. So we probably need to include some trait. So I included here the trait stream external, yeah, which implements all kinds of handy methods essentially on futures and streams. As you can see, right, we have here the next into future, which is also very cool, by the way. Map, let's say all kinds of utilities on streams. So now we have this done, right? So we're just printing the events. Then we also do here. Which one, of course. And essentially we have now a swarm 0 and a swarm 1, which has been pulled and the events are printed, right? So in theory, this should work, right? So let's run it. This will fail. And the reason is because essentially these things are being run in parallel, even though they're on the same thread. But the listener won't be started before the dialer does that. So we will probably see some kind of connection error because the dialer says, okay, I cannot connect to this peer. And this also shows that libp2p doesn't implement any dialing, right? Or let's say dialing logic. So it's like really like let's say a very fundamental piece of software which you can tweak and tune to your needs, but really doesn't do that much, right? Okay, so here we get the same error, right? That's what it's swarm dummy behavior, but I think we got now the behavior dummy behavior. Exactly. I don't know really what dummy behavior does, but it's probably something very simple. Okay, so these need to be mutable because the pull next is mutable. So let's fix this. And I think now we've got some code we actually can run. So let's run it. Test. And it's running, but let's see some output. Capture. So no capture essentially means, okay, I want to run the test, but I just want all the output to actually be printed. And what we get here is what we expected. So we got a new listen address, right? And we got an outgoing connection error, right? Which makes sense because it's not typed correctly. So the most simple change would be essentially to wait for dialing a little bit before we continue. Right? So wait for 1 second before I make sure someone's listening. So go. So I included all, so with all the features just to make it easy, right? Okay, so now we're waiting 100 milliseconds, which should be enough as well. So let's try it. Okay, so now essentially our first little the peer-to-peer project seemed to be working because we have now swarm 0, which has a new listen address. Swarm 0 has an incoming connection, right? Because this was the listener. And this is interesting because this is actually a parameter, right? You will see later, which says, okay, which you get a unique connection ID, the local address, the send back address, that's the address we know is from the other peer, right? Which got this random port. And swarm1 gets a connection established event with the unique peer ID, right? Which has been generated by the new identity, which is the public key of the peer, the first connection ID. The endpoint, the role of the endpoint is it was a dialer, because swarm1 actually dialed, and none establishes 1, no errors. And establishment in 7 milliseconds, which is like a lot, to be honest, but okay. And then swarm1, now immediately close connection, and this is going to be very interesting because here we get the keep alive stuff of libp2p, essentially, kind of. Okay, I think we covered already like a lot, let's say, in this first episode on generating, let's say, our little custom protocol in the peer-to-peer. I hope you enjoyed it. Please like and subscribe, right? If you like this content, and ask any questions in the chat. I will try to answer them. And I will see you next time. Thank you very much for listening.